Hello, in this video I'm going to explain a problem about electric charges, and in this case is a problem where it's stated there are 2-point charges. The first one is located at the points -3x and -5y, and it's located and the point charge has a charge of +6q. At the origin, we have a charge that has a charge of -2q, and it's asking where can we put a third charge so that the net force at that point it's equal to 0. Here, as you can see, it's an inclinated plane, but we can make it horizontal so we don't have this problem of the angles at first. So I'm gonna state the same problem, but in a horizontal line, where we will ask ourselves, where should we put the third charge? If we put it over here, the charge, as this charge is much bigger than this one, the charge would be much more repellent than attractive, and the net force would never be 0. So for example, if we look at it here, what I'm trying to say is that the force would be like that in the repellent, because it will be like 6 pushing away in a very short distance, and -2 like attracting with a bigger distance, so that doesn't work. If we locate it here, and this here, we would have a very repellent over here and a very attractive over here, so the net force would never be 0 again. So the only part where we can put the charge is in this side. So that's how we're gonna answer the problem. So if we locate a positive charge, let me do it positive. This distance would be x, alright, and this distance would be x plus the radius between, the distance between charge 2 and charge 1, which we will catch up later on. So, if the net force is equal to 0, that means that force 2 to 3 and force 1 to 3 are equal. So we can do that. Force 1 to 3, it's equal to force 2 to 3. And if we remember the law of Coulomb, that states that we have K multiplying charge 1 multiplying charge 3 over radius squared, it's equal, in this case, it's equivalent to the force from 2 to 3, K Q2 Q3 over radius squared. And in this case we know that this radius, it's x, because it's from 1 to 3. This is 1, 2, and 3. And that this radius, it's x plus r, distance from 1 to 2 squared. We can start eliminating some constants. For example, k. For example, the magnitude of the charge Q3, and we're left with that. Oh no, with this. Okay, so now, oh, very important thing is we're not working with well, as we're working with distances in a plane. In this case, we're gonna consider the charges, or well, the equivalents, as absolute values. So this will be the absolute value, and this will be the absolute value. That stated, we'll remember along our problem that we cannot use the negative charge because it will affect our result. So we have that quadratic equation cuadrática over here, x plus r squared multiplying q1 equals x squared multiplying q2, and we know that this can be solved as x squared plus 2xr plus r squared. All right. That be multiplying by the absolute value of q1, that it's 2. That's equal to x squared multiplying q2, the absolute value of q2, that is plus 6. All right. So we have we can start locating some values. For example, let's solve the distance between 1 and 2. As you can see, this is a vector because we have 2 coordinates and a line that connects them. So we can get magnitude of this triangle as the distance r is the square root of 5 squared plus 3 squared, and that is the square root of 34. Square root of 34, 5.8. So we've got here, and we know this is 2, and we know this is 6. We got 2x squared plus 2 multiplying another 2. 2 times 2.8 times 2, 23.2x plus the square root of 5.8, no, the quadratic, yeah, 5.8 2 squared times 2, which is 67.28. It's equal to 6.8 squared. And so if we solve this equal to 0, well, we like to have it equal to 0, we would have 4x squared minus 23.2x minus 67.28, which is, let me see if I don't have it over here. Well, no, I don't think I have it. For 23.2 minus 23.2 minus 67.28. I've got two distances. The first one, it's minus 2.12, and the second solve of x is 7.92. So which one do we choose? Well, we choose the one that states that it's in this quarter of the plane. So we'll use 7.92. And to solve the coordinates, which is what they're asking, we'll use triangles. So we'll have 7.92 multiplied by 3 over 5. That's the x coordinate, 4.75, and the y coordinate 7.92 multiplied by, oh wait a second. Okay, so here we have an angle alpha, and here we have an angle beta. So we got the tangent of minus 3 over minus 5, that's 30 degrees, right? And as we will use the complementary angle, because we have this angle beta over here, we'll use the cosine. Well, it's 7.92 cosine of 60 and 7.92 sine of 60, which give us the values 3.98 and y is equals 6.90, and that's our answer.